Alright, hello algebra fans. Now we're going to work on a different type of compound inequality. We're going to work on AND problems and between problems. They're really kind of the same type of problem, but we're going to talk about them separately. So the first are AND problems. Okay, so let's start out with a basic problem that's really already solved. If I have x is greater than 5 and x is less than or equal to 7. Now the key here for an AND problem, the solution to an AND problem is basically where, whenever you graph it, it's where the lines overlap. Now remember, with an OR problem, it's where you saw a line. Wherever there was a line on the graph, that's part of the solution. Now you're going to see where those lines are going to overlap. Okay, that's your solution. So if I graph this, I have it's greater than 5 and less than or equal to 7. Okay, the overlap is right here. So what you're going to do is those values are going to be between, or the solution is going to be between 5 and 7. So this is how you write a solution to an AND problem. You always, and this is always the case, you write an x in the middle, and then that's an open dot, so it's going to be less than, that's a closed dot, and that's going to be less than or equal to, and then you literally transfer these numbers down here. So it's a 5, and this number down here. And the way you say this is x is between 5 and 7. And notice the inequalities. The inequalities are pointing to the left. They will always point to the left. If they're not pointing to the left, you're going to have to switch them around, but at least for the first few problems, they are always going to be pointing to the left. Okay? And that's pretty much it. That's what that means. It means x is between 5 and 7. So this is really what's on an answer blank. And then on the number line, this is actually your work in progress number line. Okay? And then your final answer is going to be between 5 and 7. So we're going to put that. It's going to be an open dot, a closed dot here, and that's your answer on a number line. So two parts. First part is the actual solution as a between. Second part is a number line. So let's just actually do a few more problems just to be able to graph, to make sure you guys understand how to graph it. If I graphed, and I'm not even going to write up the inequality, but let's just say it's -5 and -2. And the graph looked like this. It was greater than -5 and less than or equal to -2. You are going to write this as a solution. You're going to say x is, and then again, this is an open dot on the left hand side here for the -5. So less than -5, and this one is going to be, or sorry, it's greater than -5, and this one is going to be less than or equal to -2. That's the inequality for that graph. And then if I actually make my final graph, it's going to be between -5 and, oh, it's always good to put another point in here, -3. And this is -3 and -2. And here is your solution. Okay? So it's between -5 and -2, and here it is, between -5 and -2. Now sometimes people get confused and they're like, well, wait a second, I don't understand. How is this, the arrow's pointing to the right, this arrow's pointing to the right, but yet it looks like it's pointing to the left. Well, you need to realize that if I rewrite this, this is actually, I can flip it around. That's actually saying x is greater than -5. Because whenever you solve it, that's really how, what you do is you have x's on the left hand side. So it's saying x is greater than -5, and this part right here is saying x is less than or equal to negative 2. And that's exactly what we graphed in the original problem here. This is exactly what we graphed. Okay? So let's try another one. If I have negative 7, 0, and 5, and I'm going to have that and that, and that's going to be what you're going to graph. That's what you've graphed, and then I need to come up with a solution. So again, it's going to be x. This is an open dot on this side here now, so it's going to be less than or equal to, but it's really x is greater than or equal to negative 7. Okay, so it's negative 7 here. That's an open dot here, so it's a less than sign, and it's 5. And that is the inequality for that graph. And again, if I graph it, negative 7 and 0 and 5, and it's going to be fill dot, open dot, and that's my solution. Okay, so that's the idea behind just graphing it. Now let's actually do some problems where we have just to do a little bit more work. So if I have a problem that looks like 2x plus 3 is less than or equal to 11, and x plus 8 is greater than 2. Okay, so we solve it just like normal here. Negative, or subtract 3 from both sides. So you get 2x is less than or equal to 8. Divide both sides by 2. X is less than or equal to 4. And we subtract 8 from both sides. We get x is greater than negative 6. Okay, so it's an and. That's between these is and. So what you're going to do is you want to graph it. That's actually your first step, is you graph this. Here's negative 6, 0, and 4. It's greater than negative 6, less than or equal to 4. So again, this is not your final graph. If you put this as your final graph on the answer blank, you're going to lose a point off of that because this is not a final graph. What you need to do is you need to now look at this and you say, oh, well, x is between, so again, here it's between these two values because that's where it overlaps. So x is, and you're going to draw your inequality because it's an open dot, negative 6, and it's a closed dot, 4. So that is on one blank, and then your other blank is going to be the number line, and you just write out the answer. So it's between negative 6 and 4. And that's what your graph looks like. Okay? Very simple. Solve it just like normal, and then you write it as a compound inequality, like a between problem, and then you graph it. And again, this negative 6 goes with that negative 6, that 4 goes with that 4, and then you have your inequality problem parts here, which are going to be your open circle and closed circle. And then you make sure you put the line in between them. Okay? Very simple. So let's do another example here. All right. If I have 3 minus 2x is greater than negative 7, and 5 minus x is less than or equal to negative 7. Okay, so obviously, well, what's going to happen is we're going to solve it. We're going to subtract 3 from both sides, and we're going to get negative 2x is greater than negative 10. You divide by negative 2, and make sure when you divide by a negative, because there's a negative right here, and that's in front of the variable. So when you divide by a negative, we got -2 for both sides, make sure you flip that inequality sign around. That is the most important thing with inequalities. So we get x is less than +5. Okay, so here I'm going to subtract 5. I get negative x is less than or equal to -12. Divide both sides by -1. So x is greater than or equal to +12. Okay, so let's graph this one. Here's 5, and here is 9, and here is about 12. Okay, so x is less than 5, x is greater than or equal to 12. Now remember, an AND problem is where the lines overlap. There is no overlapping here. In fact, this area right here is blank, right? There's no overlapping at all. So if there's no overlapping, the answer to this problem on the blank is no solution, baby. All right, there's no solution to this problem. And then if I want to graph a no solution problem, remember, you draw a number line and you put a slash through it. So that is going to be the answer for this problem. Okay, very important. If there's no overlap, it's no solution, and you describe it with no solution and then also with a slash through the number line. As opposed to an OR problem, OR problems can never be no solution. That's important. An OR, so let's write this out here. OR problems, which is the day before, that one is going to look like this for our purposes. Either that way, or it's going to be all real numbers. One of those two. An AND problem is going to look like this. So it's between, or it's going to be no solution. Okay? You will never have an OR problem that's no solution, and you will never have an AND problem that's all real numbers. It's only this case. The OR is going to be one of these two cases, and the AND is going to be one of these two cases. It's very, very important. Okay, let's try another AND problem here. 2x minus 4 is less than or equal to -6. And 3 minus x is less than -10. Okay, so we're going to add 4 to both sides. So you get 2x is less than or equal to -2. Divide both sides by 2. We didn't divide by a negative, so we keep the inequality sign the same way. X is less than or equal to -1. Okay, subtract 3 from both sides. X is less than -13. Divide both sides by -1. X is greater than, flip the inequality sign, 13. So you can see what's going to happen right away again. Here's -1, 0, and 13's out here. It's greater than 13, less than or equal to -1. This again is going to be no solution. The number line is going to look like that. All right, let's try one more AND problem. Oh, actually, in this last problem, it's always nice to see the word AND here. Okay, that's actually, you're always going to see the word AND. So you'll know, there will be no confusion if it's an AND problem or problem. You'll see the word AND, or you'll see the word OR. All right, so let's try one last problem. 4 minus 3x is less than or equal to -8, and 2x minus 3 is greater than 3x minus 9. All right, so we're going to subtract 4 from both sides. So negative 3x is less than or equal to negative 12. Divide both sides by negative 3. You switch the inequality sign. X is greater than or equal to 4. Okay, pretty mellow. The next one, add 3 to both sides. So 2x is greater than 3x minus 6. Subtract 3x from both sides. Remember, you're getting your variable to the left-hand side. So it's negative x is greater than negative 6. Divide both sides by negative 1. X is less than positive 6. So if I graph that one, 4, 5, 6, greater than or equal to 4, less than 6. Again, this is our working number line. This is not our answer blank. Our answer blank is over on the side. So I require you guys to show me a number line before you graph the final number line. So you're going to have an answer blank and you're going to have a number line on the side here. And you're basically saying x is between 4 and 6. So x is between 4 and 6. Here's the closed dot, here's the open dot, and there's the inequalities right there. And then your graph is going to look like this. 4, 5, 6, between 4 and 6. So that's basically what and problems are. We've done a lot of examples, and that's the look of it. Now, later on in Algebra 2, you're actually going to do problems that look like this. I'll just do one quick example. Let's just say 3, 4, 5, and let's say it looked like this. Let's say they pointed the same way. Now you remember, an and problem means and is where they overlap. And where does everything start to overlap? It starts to overlap right here and goes out. So you're going to tell me basically the solution to this problem is x is greater than or equal to 5, because it's got a solid dot here going to the right. Okay, so that is what an and problem solution would look like. And then your graph would look like this. You'd have just one line going like that. Okay, let's say this exact same problem, just to review, was an OR problem. So if this was an OR problem, remember this is the solution is where you see the line. Well, I start to see the line right here. That's where I see the line. The line starts here, and it's great that it overlaps here, but the line actually starts here, and so it goes on from there. So this solution is just a little bit different. That one's actually saying x is greater than 3. Again, that inequality is an open dot, so it's greater than 3. And then if I'd graph this one, it's an open dot pointing that way. So that's the difference between or and and. And is where it overlaps, or is where you start to see the line. All right. Last type of problem is called a between problem. And we've actually done those now when we've done and problems. So you've heard me talk about that. If I give you, and basically this is what a between problem is. If I'll say x is between negative 3 and 2. We've already done that. You guys know how to graph that already. Negative 3. Negative 3, 0, and 2. It's between open dot and closed dot. It's between those two values. That's all you have to do. So if I give you something like that, you are going to graph it just like that. Now, how does it get a little more difficult? Well, if I have a problem like this, x plus 1 is between negative 3 and 2. Your goal here, math fans, is you want to isolate the x, or the variable. So this is just like if I told you x plus 1 equals 2. How do you solve for x? You would subtract 1 from both sides, and you get x equals 1. Well, that's what we're going to do, is you want to look at this part right here and say, I want to solve for x. Oh, okay, I subtract 1, but you have to subtract 1 from all 3 sides. So now, before you did it from 2 sides, now you have to do it from all 3 sides if you want to do anything. So you do that, and you get negative 4 less than x less than or equal to 1. And then you graph it. Negative 4, 0, 1, open dot, close dot, and that's your answer. Between negative 4 and 1, that's your solution. Okay? So let's try a little more complicated one. If I have 2x plus 7 is between negative 3 and 1. Same thing, it's like saying 2x plus 7 equals 1, or negative 3. The first thing you're going to do is you're going to subtract 7 from all 3 sides. So you get negative 10 less than or equal to 2x less than or equal to negative 6. In your last step then, just like this one, I subtract 7. So you get 2x is equal to negative 6. You're going to divide both sides by 2. So I'm going to do that. I'm going to divide all 3 sides by 2. So you get negative 5 less than or equal to x less than or equal to negative 3. Very simple. Graph it. So negative 5, negative 4, negative 3. It's between those. And this actually should have just been less than. Okay, so it's between those. So this is a solid dot. This is an open dot. And there's my graph. Very simple. Okay. Another problem here. 3 minus 2x is between negative 5 and 9. Same thing, you're going to subtract 3 from all 3 sides. So you get negative 8 less than negative 2x less than or equal to 6. Okay, now I'm sure a lot of you recognize, you're like, wait a second, you're about to divide by negative 2. And you're right. And what happens when you divide by a negative? You switch around the inequalities. So in this case, we're going to switch around both inequalities. It's going to be 4 greater than x greater than or equal to negative 3. But remember what I told you at the beginning of the lesson is that the inequalities will point, or will always point to the left. These are pointing to the right. So what you're going to do is you're going to switch them around. The way you switch around is you literally take this whole thing and you completely flip it around. So it's negative 3. It's pointing to the this guy's pointing to the negative 3. X. This guy's pointing to the x. And 4. I literally flipped the whole thing around, so now it is pointing to the left. Now I graph it. Negative 3, 0, 4, and this is a solid dot, this is an open dot, and that's my graph. Okay? If you try to graph this one right here, you would actually make a mistake because you would try to put the 4 on the left-hand side. It would look like this. You'd do the 4 here and the negative 3 here, and you know it can't be that way anyway because 4 has got to be on the other side. 4 is greater than negative 3. Okay? So you would not do it that way. You would actually flip around everything and get the inequalities pointing the correct direction. Okay, so that's pretty much it. Again, this is a between problem. We've had and problems. The lesson before were or problems. So those are really the 3 different compound inequalities. So that's it, and I hope you learned something.